Hi everyone, I hope you are doing great. Today, we are going to focus on HCS examination questions. To be specific, the Elective Mathematics July 2020 questions. The theory part. I want us to consider the question 1. It states that an operation is defined on a set of R real numbers by A star B being equal to A plus B plus 2AB, where A, B belong to R. I calculate bracket open 2 star 3 bracket closed star 5. The you have to find the true set of the equation A star 7 is equal to bracket open A star 5 bracket closed plus bracket open A star 2 bracket closed. It says if A star B is equal to 0, express B in terms of A, hence state the largest possible domain of B. And then we come to B, we have the question, find the true set of x squared plus 4x minus 21 is greater than or equal to 0. So today we will be focusing on this question. We try solving them. Okay, so we start with the first question, that is the I. It says that we have to calculate bracket open 2 star 3 bracket closed star 5. Okay, so question like this, all that you have to do is bracket first. We try simplifying what we are having in the bracket, but don't forget the definition for the star operation. The star operation has been given. It was given as A star B is equal to A plus B plus 2AB. This was the definition given. So the A is representing the number before the operation, and then the B is representing the number after the operation. So from this particular example, our A is the 2 and then B becomes the 3. Okay, so we try simplifying what we are having here first. So we have our 2 star 3, and this will be equal to, we have 2 plus 3 plus 2 multiplying the A and then the B. Alright, so we try simplifying that. Now 2 plus 3 will give us 5 plus 2 times 4 times 2 times 2 times 3, and that will give us 12. Alright, so we have 12. Therefore, when we simplify this gives us 17. Okay, so it means that the 2 star 3 is equal to 17. Therefore, we are going to substitute the 17 into where we have the 2 star 3. Therefore, we are going to have 17 star 5. And this is equal to 17 plus 5 plus 2, 17 times 5. Okay, so the 17 plus 5 is going to give us 22 plus what we are having here, the 2 times 17 times 5, and that one too is going to give us 170. So we try simplifying this, and this give us 192. So it implies that what we are having here, the 2 star 3 star 5 is equal to 1 9, 2. So that is the I. We move on to the I. For the I, it says find the true set of the equation A star 7 is equal to A star 5 plus A star 2. This is an equation. So we are going to simplify what we are having on the left hand side, likewise what we are having on the right hand side. Okay, so for the left hand side, we have the A plus 7. Don't forget, we are still using the same definition, that is the A plus B being equal to the A plus B plus 2AB. The same definition is what we are using. Okay, we can try and solve it at a go, or what we can do is we try solving the terms having the operation separately. When we are done, then we substitute them into the equation. Okay, so when you take the A plus or A star 7, this will be equal to A plus 7 plus 2A multiplying 7. So we try simplifying this, and this will give us A plus 7 plus this becomes 14A. So when you simplify this gives us what? A plus 14A is going to give us 15A plus 7. Okay, so we come back to this particular one, the A star 5 also. So we have the A star 5, and this will be equal to, we have our A plus 5 plus 2A 5. Alright, so with what we are having here, this will give us A plus 5 plus this one too is going to give us 2 times A times 5, and that is 10A. Okay, so we are going to have our 10A. This A plus 5 plus 10A is going to give us 11A plus 5. Okay, so we are left with the A star 2. All right, so we have our A star 2, and this one too is going to give us, we have the A plus the 2 plus 2, we have the A and then the 2. Okay, so with this we are going to get our A plus 2 plus 4A, and when we simplify this is going to give us, we have our 5A plus 2. Now we have expression representing the terms having the operation, so all that we have to do is to substitute them back. So we are saying that A plus 7 is equal to 15A plus 7. A star 5 is equal to 11A plus 5, and then A star 2 is equal to 5A plus 2. So let's do the substitution. So we are going to have, therefore we have 15A plus 7 is equal to the A plus 5, which we had the 11A plus 5. So this one will give us 11A plus 5. Okay, plus then the A plus 2, that is the A star 2, gave us 5A plus 2. So we write our 5A plus 2. Okay, now we have terms having A and then constant, so we try grouping terms, or we can decide to even simplify what we are having on the left hand side and then the right hand side. Okay, so we have 15A plus 7 being equal to this time we have 11A and then a 5A. When they add, this will give us 16A. So we have 16A plus 7. Okay, so now we can group the terms having A to one side and then a constant to one side. So for this side we have 7 This 7 crosses the equal to sign, you have minus 7 is equal to this side, we have 16a. This is 15a. It comes here, it becomes minus 15a. 7 minus 7 is going to give us 0. This is equal to a. So therefore, we have our a to be equal to 0. And this is the I. Now let's move on to the I. For the I, the question is, if A star B is equal to 0, express B in terms of A, hence state the largest possible domain of B. What the question is asking you to do is to try expanding the A star B using the definition for the star operation. When you are done, try making B the subject. Make sure that B stands on one side of the equal to sign, such that on the other side you are going to have A there. When we are done, then we try analyzing the expression, that is by finding the domain. Okay, so we know that per the definition, we know that A star B is equal to A plus B plus 2AB. So from this equation, where the A star B is, we are going to substitute the A plus B plus the 2AB there. Therefore, we are going to have A plus B plus 2AB. This is equal to 0. We want to make B the subject, so the terms having B, we maintain them at one side, then we shift the other terms without B to the other side of the equal to sign. So we have B plus 2AB. This will be equal to, we shift the A to the other side, and that becomes, we have 0 minus A. Okay, with this, B that we want to make the subject is common here, so we try factorizing the B. So the B comes out, we open bracket, we are going to be having 1 plus 2A here, we close the bracket. This is equal to 0 minus A gives us minus A. Now we are having B multiplying 1 plus 2A is equal to negative A. We want to make B the subject, so what do? We try dividing both sides by whatever expression that is attached to the B. So we are going to have our B, we have 1 plus 2A all over the same 1 plus 2A. Thus is equal to, you have minus A, you have 1 plus 2A. So this can cancel this. Alright, therefore, what are you left? We have B being equal to minus A all over 1 plus 2A. Okay, so with what you are having now, B, or we have been able to express B in terms of A. This is because we have B standing on one side of the equal to sign, and the other side we have A also there. So that is the first part of the question. The second part, it says, hence state the largest possible domain of B. B, or the expression representing B, is a fraction. So if you want to find a possible domain of B, all that we are trying to say is find the value for A that will make this particular expression defined, because domain is the set of possible values that makes a particular function defined. Therefore, if we are having a fraction, this function in particular, or this fraction in particular, is going to be defined. This particular function is defined only when the denominator is not equal to 0. So what value will make this particular expression to be undefined? Because it's a fraction, so we need to get that value. Therefore, for the domain, we take the denominator, that's 1 plus 2a being equal to 0. When we try, so we just take the denominator, then we equate it to 0. We solve for the value there, that is, we solve for a there. So we are going to have 2a being equal to -1. We divide both sides by 2. Now we are having a to be equal to -1/2. So with this, other way of saying is when a is equal to -1/2, the denominator is going to be 0. And when the denominator is equal to 0, b will be undefined. So our domain for b domain of b will be a is such that a belongs to all real numbers, that a should not be equal to -1/2. So that is the domain of b, because any value will make this particular expression defined apart from -1/2. You can use your calculator to verify. Substitute -1/2 into this expression. The denominator is going to be 0. And if the denominator is equal to 0, then this function is undefined. So the possible values, or let me say the largest possible domain of b, is what we have, that is a is such that a belongs to all real numbers, a is not equal to -1/2. Now we move to the last part of the question. The last part of the question, you have to find the true set of x squared plus 4x minus 21. This is quadratic inequality. Okay, so for quadratic inequality, we have the graphical approach or the number line approach. So we try using one of them to solve or to find the true set. First, what you have to do is solve the quadratic equation, or you factorize the quadratic expression there. So we have x squared plus 4x minus 21 is greater than or equal to 0. So we take the quadratic aspect. Okay, we try factorizing that. So we have x squared plus 7x minus 3x minus 21 is greater than or equal to 0. The reason why we are having the 7x and then the 3x here is, if you want to factorize this particular quadratic expression, the coefficient of x squared is 1 and then a constant is -21. So when you multiply, you get -21. Now you look out for two numbers. These two numbers are going to be factors of the -21. That is what we had after multiplying the -21 and then the +1. When they multiply the one that we had, that is -21. You try finding factors of this 21, or two numbers in which when you multiply, you get -21. But when you add, you get the 4, and that is 7 and the -3. That is how come you're having the 7 and the -3 here. So we take the first two, we factorize. So we have x, we're going to be left with x plus 7 minus 3. We have the same x plus 7. This is greater than or equal to 0. So this gives us our x plus 7, and then x minus 3 is equal to 0. Alright, now we just change it to equal equation. So x plus 7, x minus 3 is equal to 0. We want to really find the true set of this. So at this point, we change the inequality sign to equal to sign. We solve for the values, then we try analyzing the values. So we take each factor, then we equate it to 0. Therefore, we are going to have x plus 7 is equal to 0. This implies that we have x to be equal to negative 7. Then for this one, that is the x minus 3 being equal to 0. That one, we are going to have our x being equal to 3. So these two values, we are going to analyze them. Now, if you want to use the graphical approach, so let's assume that we have our graph here. This is not drawn to scale. All right. And we are assuming that we have our negative 7 somewhere here. Then we have our positive 3 also here. Okay. Now, this particular quadratic expression, if it were to be an equation, when you solve this particular, or when you graph this particular equation, the curve is going to be the U-shaped type, all because the coefficient of x squared is positive 1. And when the coefficient of x squared is positive 1, or is positive, when you always graph that quadratic equation, you're going to get your shape being the U-shaped type. Okay, so our shape is going to be something like this. All right. Okay, as I said, this is not drawn to scale, so this is going to be the nature of our shape. But because we are having greater than or equal to, we try shading the upper part, and thus we can shade up to positive infinity. We come to this side to the same thing, because it is greater than or equal to, we try shading this, and we can shade this particular one to up to this direction, that is positive infinity. Okay, so in that case, when you consider this particular one, shading from negative 7 up to negative infinity is going to give us x being less than or equal to negative 7. When you consider this particular one too, we can shade from this point up to positive infinity, and this one too is going to give us x being greater than or equal to positive 3. And these values, or this range of values, is going to make the function defined, therefore being the truth set. So we are going to have our truth set to be equal to, we have x is such that x is less than or equal to 7, or x is greater than or equal to 3. Sorry, this side is negative 7. All right, so that is that. If you have any questions concerning this particular question, or any comment, feel free to add your comment. Your comments will be much appreciated. All right, I thank you for your time. Stay blessed.